So today we are covering 10.1 and 10.2. This is working with angle pairs and special pairs of angles showing up as well. So we're going to start with our main core definition of what an angle is. So we have two lines, line segments or rays, connect at a common point. The angle is the space between these two lines. Again, one that we've probably seen before, have a different or a fairly regular idea on, but getting our exact definition down there. Angles are going to be measured in degrees for this class. When you move on to, it's pre-calculus is where we first start seeing this. There are other ways to measure angles, one of them is being radians, but we are not going to be using that. We're just going to stick with degrees for this class. Now we're working with angles. We have some different classifications as we are going through these. We have acute angles, so it means all angles that measure less than 90 degrees. We have right angles, which are all angles that measure exactly 90 degrees. And I'll show you guys a nice little trick to identify right angles here in a second. Obtuse angles are angles that measure greater than 90 degrees, but less than 180 degrees. And then straight angles are angles that measure up to exactly 180 degrees. And it's pretty much just a straight line. We've got some fun details that come out about straight angles here in a little bit also. So part of the things that you're going to be doing on the homework is going through and identifying, okay, we've been given a couple angles. Is this thing acute? Is it right? Is it obtuse? Is it straight? It's identifying those. So I'm going to jump us over to the whiteboard. I'm going to make up a couple of those really quick. We'll go through a couple really quick examples of these. So if I have something to the effect of if I have been given that, this angle of 53 degrees, and we're told classify this or identify this angle to be either acute, right, obtuse, or straight. All we need to do, go back to our classification requirements that we just had, and we say, what's the requirement to be an acute angle, a right angle, an obtuse angle, or a straight angle? And then all we're doing is writing in or using a drop down to say, this thing is one of those. So looking at that definition, the definitions that we have, all angles that measure less than 90 degrees are considered to be acute angles. So our answer for this one would just be acute. If we had a drop down or anything like that, then you just try and find it in there, or you would type in acute. I believe it's set up to be a drop down, like a multiple choice thing. So if we had something, let's say, like this. So given this angle, we are told it's 140 degrees. May not necessarily be drawn to scale because I'm not the greatest artist in the world, but we get the point here. So again, we're classifying this thing as either acute, right, obtuse, or straight angle. So we look through our definitions. An acute angle, all angles that measure less than 90 degrees, so it's not that. Right angles measure exactly 90 degrees, so it can't be that. Obtuse angles are angles that measure greater than 90 degrees, but less than 180 degrees, which means this thing is an obtuse angle. Just write that in, or we would use a drop down. We'd have our answer there. There we go. Now we're going to go through another one here because this is one of the weirder forms that we get. There's a really nice implication that goes along with this one. Whoops. There we go. And we're being asked once again, we need to label this thing as either acute, right, obtuse, or a straight line. You might be looking at this going, well, okay, I've not been given any measurement of this angle. I don't know what the degrees are, degrees is for this thing. That's understandable. When we have been given this square in here, it doesn't exactly look as great because I didn't draw it as well, but when we have that square showing up, I'll try and make it a bit better here. Anytime we have that little square right where an angle meets, that implies that that measurement angle is 90 degrees. So it's not going to be written in explicitly saying this thing is 90 degrees, but it is implied by having that little square there that this measurement actually indeed is 90 degrees. So based on that fact, this is going to tell us that we have a right angle. My pen's are going to decide, the pen's going to decide to write how I want it to today. That'd be lovely. There we go. So here we have a right angle. And again, right angles have the really, really nice quick thing to reference of, is there a square in there? At that angle point, yes, bam, right angle. You can default right to that. And our last one, we have this thing as an acute, right, obtuse, or a straight angle. And it might not look it with the way I have drawn it, but this is supposed to be just a straight line. So a straight line is always going to equate to being a straight angle. If we were to take, let's say, here's roughly the center of this thing. What's the angle measurement along that? Well, it creates a 180-degree angle. And that's where we get this idea of calling these ones a straight angle. It just creates a straight line. So as you're going through these on the homework and they're asking you to identify these, just go back to our definitions that we have of the different types of angles and then see, based on what you've been given, which category does it fall into. I'm going to move us over here when we get to other examples. Go back to our notes in the meantime. So now we're going to go through some angle pairs that are showing up. And again, hopefully you're seeing it. This is everything from 10.1. Not a whole lot to it. So we're going to combo with 10.2 here in a second. So some angle pairs that show up. Our two main ones that we see more than anything else are referred to as complementary angles and supplementary angles. So complementary angles is when a pair of angles adds up to equal 90 degrees. We may not necessarily know the measure of each of those angles individually, but we know that when we add them, their total is going to be 90 degrees. Similar with supplementary angles, we have a pair of angles that adds up to equal 180 degrees instead. So again, we may not necessarily know what each of those angles are specifically, but if we are told that they are supplementary, then we know that they absolutely must add up to equal 180 degrees at the end of the day. So these are our two main ones that we have showing up here. And if we have any pairs of angles that add up to something other than 90 or 180, there's not really a special classification for it. So if you're asked, define the classification of two angles that add up to 120 degrees, you would answer that with, there isn't a special name for that. These are the only two angle pairs that we have that have really special properties attached to them. So two very specific ones, everything else, it's not that special. So we're going to go through a couple examples here, and we'll figure out how we can work with finding the missing angle for a complementary, supplementary, or neither angle showing up there. So we'll jump back over to our whiteboard. find the missing angle. So for our first example, let's say we have, I'll draw this out here. We have angle A, we have angle B. Okay. We'll say A and B are complementary. And we'll say that angle B is, let's make that 27 degrees. So we have two complementary angles, and we know the value of one of them. So by our property that we just went through, if two angles are complementary, then that means they have to add up to equal 90 degrees. So let's write our very generic formula for that. I have angle A plus angle B is equal to 90. Again, I don't know A and B right now necessarily. I'm just writing my general formula. And I know that these two angles have to add together to give me 90 degrees. And then looking at the information that I have been given, I have been told that angle B is 27 degrees. So I need to find angle A. So in our formula that we just created directly below that, we don't know A, so we'll leave it like that. We know angle B to be 27. And we know that those add together to give us 90. And now we just solve for A. So I'm subtracting 27 from both sides. And A is equal to, what's that going to be, 63, I'm going to say. So the measure of angle A is going to be 63 degrees. So we'll take a look at another example here. So let's say we have, let's go here. And we'll have angle A, we'll have angle B. We'll go with the assumption that A and B are supplementary. And we'll say that angle A is 130 degrees. So we've been given some information about these two angles here. They're supplementary. We know the value of A, so that's fine. But we need to find the missing one. So by our definition, again, supplementary angles, when we have a pair of angles that adds up to equal 180 degrees. So again, let's write our generic equation of that, and then we'll fill things in accordingly. I know angle A plus angle B should equal 180 because I have been told that these two angles are supplementary. That's one of our buzzwords. If you want to think on a lot of these as looking for buzzwords to solve these, supplementary, complementary, really good ones to have nailed down, or at least be on be on the hunt for, as it were. So we've been given the value of A of 130, so we're just going to plug that in for A. And then we're solving for B. And we're doing everything that we've done in the past, just subtract 130 from both sides. And we get that B is equal to 50 degrees. And if it's any other instance where we don't have two angles that are complementary or supplementary, then again, we have to be told how much the two angles add up to in some way, shape, or form. And then they have to give us the value of one of those angles. So keep an eye out for when you're going through these, how much do the angles add up to? And how much do we, or what's the measurement of at least one of the angles that we have been given? And again, look for those buzzwords of complementary and supplementary. That really helps hit home, oh, I'm adding up to 90, I'm adding up to 180, something to that effect. So we'll go back to our notes here, and we'll get going on the 10.2 material, because that's everything for 10.1. Now 10.2 has us working with more special angles of pairs, or special angle pairs, I should say. And we're going to reference our example, kind of our generic example that we have here, and then we'll go into one with some numbers down below here in a second. But our first one that we're looking at, so we're looking at two intersecting lines and the special angles that are created by them. So we have angles 1, 2, 3, and 4 here. And based on we're going to go through our definitions, but these are the pairs that we're going to be referencing, the angles I'm referencing as we go through these examples. So our first one that we have is adjacent angles. And it's angles that share the same vertex and one common side. They combine to make a straight line, then adjacent angles must add up to equal 180. So a couple adjacent angles in this picture that we have would be angles 1 and 2, or it could be angles 3 and 4, or it could be angles 1 and 4, or angles 2 and 3. So we're looking at ones that are right next to each other and would otherwise form a straight line or a straight angle showing up. Then we have vertical angles. These are angles that are directly opposite of each other. The other really nice part about vertical angles are always equal in value. So based on our picture example that we have up here, angle 1 and 3 are vertical angles. Angles 2 and 4 are also vertical angles. And while it might not be written in here in this example right now, of knowing what those exact measurements are of the angles, 1 and 3 are going to have the exact same value to them. And 2 and 4 are going to have the exact same value to them, again, because they are vertical angles. It's a really, really nice property that shows up from there. So I'm going to jump us over. We're going to do one with some actual numbers with it. We're going to find the missing angles for this problem that's partially hidden down here. I'll redraw it over in our whiteboard. And we will see how this turns out and what we do with those. Oops. Cooperate with me, computer. There we go. So again, just redrawing that example over here. We were told 126 degrees, X, Y, and Z. So we need to find angles X, Y, and Z for this. And we have a couple options on how we can make that happen. First and foremost, I'm just going to put possible answers off to the side over here, so we know where we're putting everything. Now, based on the properties that we went through, we're going to use our adjacent angles and vertical angle properties with this. We have, based on our definitions, vertical angles are directly opposite of each other, and vertical angles are always equal in value. So that's going to probably give us a bit less work to do if we can identify any vertical angles here. So looking at this, we have been given the value of 126 for one of our angles. Y, or angle Y, is a vertical angle from that because it's directly opposite of that. Across the vertices is another way it can be described. And based on that being a vertical angle, and the properties that all vertical angles are equal to one another, I do not need to do any actual number crunching. I can just write in for myself that angle Y is equal to 126. So we're just identifying that those are vertical angles. Bam, we have our answer. Looking at trying to solve for angles Z and X. Well, these two things are also vertical angles, so really I just need to solve for one of them, and then, based on the properties of vertical angles, the other one is going to have the exact same value. So I'm going to solve for angle X. Now looking at that, saying, okay, well, it's right next to angle Y and angle 126, or angle that has 126 for its value. So I'm going to look at 126 and X. These are adjacent angles because they are right next to each other. And if they combine to make a straight line, which it looks like they do, it's this main line that we have right here, then the adjacent angles must add up to equal 180 degrees. So that tells me that 126 plus X is going to give me 180. And again, I'm referencing this line here. I'm referencing these two angles with what we're doing down below. So I've got that set up for myself. I know these two things add up to be 180. I've got the equation written out. Fantastic. I'm just solving for X. Back to stuff that we've been doing throughout most of the quarter. And I don't know what that value is off the top of my head, so I'm going to use a calculator off screen here. So 180 minus 126 is going to give me 54. So I know angle X is 54 degrees. And again, we could go and calculate for angle Z the exact same way. We could say it creates a straight line with that angle. We could go through and recalculate that all over again. Or we recognize the fact that angles Z and X are vertical from one another, and all vertical angles have the exact same value to them. So therefore, if angle X is 54, then angle Z also has to be 54, and I don't need to do any work for that. And when it comes time on the test or the homework or anything like that, if you can identify these shortcuts, these properties, and use that to help save you some time, do it. There's nothing wrong with that. This is why we want to get all these properties down to try and save us some time as we're going through all of these. So we'll jump us back to our notes here. We'll take a look at some other stuff with this section. So that's our example that we just went through down below here. So got the right answers there. Go to our top of our next page here. So this is having us work with instances where we have lines on a plane. And a plane is just a way of saying I've got this space and I have these lines that interact with one another in a bunch of different ways. And we're going to go through a couple of these and then some of the cool, I guess, properties that show up from this also. So we have three definitions here. Our first one is that the two lines, or some of the lines that we're working with, intersect one another. So intersect is when we have two lines that cross each other in some way. They could create a very specific angle. They could create weird looking angles. All it is, I have two lines and they cross each other. Just our core definition of that. So if you ever see these two lines are intersecting, all that means is they're crossing. Nothing particularly special about that. Perpendicular is when two lines intersect and create a 90-degree angle at that point of intersection. So we can have a perpendicular pair of lines, or have two lines that are perpendicular to one another, and that implies they intersect and that they create that 90-degree angle. So if something is perpendicular, it intersects. If something intersects, it does not necessarily mean it is going to be perpendicular. It's kind of not entirely a two-way road there. And again, predominantly when we have things that are perpendicular, again, creating that 90-degree angle, we have that little square that shows up right in between the two lines that we are working with. So again, that square is going to be a bit of a giveaway for when we have a 90-degree angle and have perpendicular lines. And then last but not least is when we have two parallel lines. And parallel lines are lines that will never intersect each other. They're just going to run alongside each other forever, like railroad tracks. It's one of the ones that I've always been told to think of them as. So we'll go through a couple just quick examples of what these can look like. And I'll try and draw them as best I can because that's only going to go so far on based on my drawing skills today. But we'll give it a shot, see what we can do with that. So a couple examples here of what these kinds of lines can look like. So we have parallel lines. So these, they could be vertical to one another, but they're never going to cross. They could be horizontal, they could be diagonal, but it's two lines that are never going to cross each other. So something to that effect. And again, my drawings are only going to go so far here. If we have perpendicular, there we go. And again, perpendicular lines, based on the definition, it's when two lines intersect and create a 90-degree angle at the point of intersection. So that could look something to the effect of that. It could be slightly angled or rotated. Something to that effect. But they all create a 90-degree angle at some point where these two lines intersect with one another. And again, based on our definition of having adjacent angles and vertical angles that we just went through, if one of these things is a 90-degree angle, then that tells us that the other ones are going to be 90 as well if we go through those calculation processes. And then last but not least, and probably the more common ones that we see showing up quite a bit, is just two lines intersecting. We've seen a couple of these up to now. So it could just be written in like this. I have two lines that are crossing like that. I have two lines that are crossing maybe like this. We have not been given any kind of an inkling that these are right angles, that they're perpendicular or anything like that. So just two lines crossing. And again, these are the more common ones that we're going to see over anything else. Okay. So we'll jump back to our notes because there is one last set of things that I want to go through to bring in a lot of the stuff together. So this is the idea of corresponding angles that are formed when a line intersects two other lines, essentially when we get clusters of angles showing up here. So we're going off of this assumption of if the two lines being intersected by a third are parallel, the set of angles at both intersection locations will be identical, which means all of our previously stated rules and angle types and whatnot will still hold true, but now we're classifying and calculating angles at two different sets of locations on a picture. So we're going to be, I don't know why it's mission angles, it should be missing angles, determine all the missing angles. Like we're going on a mission here. So we have our example here. Lines M and N are parallel to one another. So we have line M, line N. They are being intersected by line L. It's going right through them. And we have been given the measure of only one angle in here. And we need to find angles A, B, C, W, X, Y, Z. And really, we only need this one piece of information. This will help us get all of it. By our definition that we went through, if the two lines being intersected by a third are parallel, which we have just been told, then the set of angles at both intersection locations will be identical. So if I can solve for angles A, B, and C up here, I then just need to plug in those corresponding values for W, X, Y, Z down below here. So I'm going to try and recreate this over on the whiteboard, and we're going to go through and solve for this. I think one of the biggest things that makes this section a bit of a struggle for some people is the fact that we have so many nice properties that show up, but we think a lot of the times that we have to do tons and tons and tons of calculations when we can let a lot of these properties that we have do some of the work for us. And that's what we're trying to do here with these examples. So I'm just going to try and recreate the graphic that we had from the other screen. It's not going to be perfect by any means, but the one I'm referencing. Oops. Better W here. And I think the other part that is useful to know, or at least I would recommend it, is for a lot of these sections, especially with chapter 10, drawing a visual for yourself goes a really long way to keep track of everything that we're doing. This chapter lends itself very, very well to visual aids as you're going through these. So as you're going through these on the homework, or even if we get to when we get to these on the test, I should say, I'm not expecting you guys to be artists. I mean, you see what I just drew here. It's nothing fancy, nothing pristine, but it gets the point across of what I'm working with. So making that little visual for yourself on your own with a scratch paper or something like that, do it. Highly recommend that. All right, but right now we need to solve for angles A, B, C, W, X, Y, Z. So we are going to work with this top cluster first and foremost. So that's what we're starting with. Now, based on our previous definitions and everything that we have, we'll work with ABC here. I'll give you guys a second or two. I'll give about, we'll say 15 seconds to think on what do I know about those four angles up at the very top. Do I know about them being maybe vertical, maybe adjacent, maybe they're supplementary, maybe they're complementary? I'll give you guys about 15, 30 seconds so to think on that on your own. And then we'll go through some of the ways we could solve that here in a second. So take a quick minute or so, and then we'll go to these. Okay, so bring it back in here now. So again, I'm looking at that top cluster of angles that we're working with. And I'm noticing that there's a bunch of ways you can go through this, but just this is some of the ways that I'm thinking on it. I'm seeing the angle 147 and C. Those are vertical angles. Vertical angles always have the exact same value to them, which means I know that angle C is going to also be 147 degrees. I also know that angles A and B are vertical angles, which means if I solve for one of them, I inherently know the value of the other one, and I don't need to do a calculation for it. So to solve for angle A and 147 are both adjacent angles, and adjacent angles must add up to equal 180 degrees. So I know 147 plus A is going to equal 180. So I subtract 147 for both sides. And I find that angle A is equal to, I want to say it's going to be 33. I'm going to apply the calculator off screen just to check that. And it is indeed 33 degrees. So I've just found that angle A is 33, not 30. There we go. And again, like I previously stated, we know that angle A and angle B are both vertical angles, which means they're going to have the exact same value. So because I found angle A, I already know angle B, and I can just fill that in as 33 degrees. So I have just finished with getting everything from that top cluster. And now, get rid of this little guy there. And now we're going to work with this bottom cluster. You might be thinking to yourself, okay, well, I've not been given any values down here, though. I can't do any of the calculations that we just went through for A, B, and C. And at face value, you're correct to think that. However, we just went through a property with these that tells us, I'm just reading from the notes on the other screen, if the two lines being intersected by a third are parallel, which we know they are, the set of angles at both intersection locations will be identical, which means now I know these M and N, these two lines are parallel. I know L intersects them, which means that each of these angles correspond to one another. So because I've already found everything in that top cluster, I just need to copy it over to the angles in that little bottom cluster, exactly where they would show up. So we have, I'm just going to write these over here and then we'll go back to it. Angles W, X, Y, and Z. So angle W and 147 go together. They're pairs there. I know angle A and angle X are going to be equivalent to one another, so those are both going to be 33. Looks like a 6 up there. Don't like that. We know angles C and angle Z are going to correspond to one another. And we know angles B and Y are going to correspond to one another. So we're just filling those in then. So we have found all of our missing angles. And we're good to go. And on the test or on the homework, if you have scenarios like this that are showing up, and you can identify and use those properties that we have or been given, don't need to do a whole lot of extra work with this. So the plus and minus that goes along with that is showing your work is going to be a little bit harder, potentially. But it also means that if we're very, very, very cautious and very, very thorough and deliberate about how we're calculating things, we can just do a lot of here's an answer and then fill in the blanks as we go through it, which is really nice. A little bit less work than previous chapters. And this is everything that we have for the 10.1 and 10.2 material. So a lot of definitions with properties attached to them. And as you're going through them on the homework, again, I just highly recommend go back and reference those because you're just going to go back to what definition are we using for this angle, for that angle, for anything like that. But that's everything for today. We'll stop the recording here and take any questions that you guys have, and we'll go from there.